Here we go with Systems 2.8. So the first one, we're just solving for the y variable. So to do that, we just get the y variable by itself. So I subtract 10x from both sides. And because I can't combine the negative 7 and the 10, I just write it y equals negative 10x minus 7. And we call it good. On number 2, first I want to distribute through here. So I get y plus 5 equals 1/4 x plus 1/4 times 4 would be 4 over 4. So just be 1. Then subtract 5, and I end up with y equals 1/4 x minus 4. Okay, now we're just going to be using some substitution. So on these first ones, they're both equal to y, so I'm just going to take one of these, substitute it in for y, and then we can solve that. So I could add 8x to both sides, giving us 14x, subtract 4 from both sides, giving us equals negative 28, divide by 14, we get x equals negative 2, so that's half our answer. So now we take an equation, plugging in negative 2 for x, and we're able to solve. So that's negative 12 plus 4 gives us negative 8 for y, so our answer is negative 2, negative 8. Okay? Alright, let's take a look at number 5 now. We'll jump down here. So now I don't have any solve for y. So I've got to figure out which one I want to solve for. I would probably solve for that y. So I need to subtract a 4x. So I get y equals negative 24 minus 4x, because I can't combine a number and the x's together. Now I can take that and substitute it in for y. So I get 6x minus. Now you still want to use parentheses, because that minus y is like a negative 1. So negative 24 minus 4x equals negative 16. Distribute the negative 1 through, we get 6x plus 24 plus 4x equals negative 16. 6 and 4, they're on the same side, so I just combine them to be 10x equals, subtract 24, and we get 40 to the negative, divide by 10, and we get x equals negative 4. So then using this, we solve for x. So we simplify this. Negative 24, negative 4 times negative 4, positive 16. Negative 24 plus 16 would be negative 8. So our answer is negative 4, negative 8. That's where they would intersect. Alright, should we take a look at 4 and 6 now? Let's clear some space. So for 4, we've already got the y and the negative 8x plus 18, so we know we can substitute this guy in for the y in the other one, because that equal sign told us we could. It told us that y and negative 8x plus 18 are the same thing. So in my other equation, we substitute out the y, substitute in the negative 8x plus 18, giving us now the ability to solve because we only have one type of variable. But notice everything here is the same except for the y. Then we simplify, so 5x minus 24x plus 3 times 18 would be 4 to 54 equals negative 3. Combine those, 5x minus 24 would be negative 19x equals, subtract 54 from both sides, negative 57, divide by negative 19, and I believe that would give us a positive 3 for x. Alright, now we've got half the problem, so we look back at this equation and say y equals negative 8, but instead of x we put in 3 plus 18. Negative 8 times 3 is negative 24, plus 18 would give us a negative 6 for y, so our answer, 3, negative 6. Alright, on number 6, we've got no variable solved for itself, but notice that x, that's an easy one to solve for. So I'd subtract a 2y, giving me x equals 1 minus 2y. So then in this equation, I replace the x with 1 minus 2y. And then we simplify and solve. So 2, negative 4y plus 4y equals negative 3. Okay, now negative 4y plus 4y is going to give us 0y, which is just 0. So 2 minus 0 is just 2. Does 2 equal negative 3? Does not. So remember, when we get rid of those variables, we can come up with different types of answers. Think about it graphically, okay? Graphically, we have three types of answers, right? We have where it intersects, and that's a point, an x value, a y value. That's an ordered pair. We also had parallel lines. That was when there was no solution. So we had that no solution, right? We also had where it was the same line, just overlapping, and that we called infinite solutions. Okay, that's what it looked like graphically. So now, algebraically, when we solve it with substitution or our other method, there's going to be three things. If we get an x equals a number and y equals a number, okay, we know there's one solution, we know that's where they intersect. If, like this, we get rid of the variables and it's not equal, that's when it's no solution. If we got rid of the variables and it was true, it was equal, that's when we'd have infinite solutions. So, for this one, number 6, the answer is no solution. Alright, looking at number 7 and 8. So here, I can easily solve for y. So I'd add an x to both sides. Y equals negative 2 plus x. Then plug it into my next equation. So negative 3x plus 3, substitute out the y, substitute in negative 2 plus x. That was a horrible plus sign. So we get negative 3x minus 6 plus 3x equals negative 6. So now, negative 3x, positive 3x, they'll cancel. We get negative 6 equals negative 6. That one's true. Okay, that's going back to this one, infinite solutions. Because any answer will work because it's always true. So we call this one infinite solutions. This is our third type of answer. Okay, that's what it'll look like. Okay, now number 8. We want to solve for that y because it's the easiest one to solve for. So I add 6x to both sides, giving me y equals 8 plus 6x. Then I rewrite my other equation and substitute in 8 plus 6x for y because the other equation told me they're the same. So negative 4x, 4 times 8 is 32, plus 4 times 6 is 24x equals 12. What am I doing? The 4x and the 24 are on the same side, so we combine them to get 20x. Subtract 32. 12 minus 32 is negative 20. Divide by 20. We get x equals negative 1. There's half our answer. So then in our other equation, we go back and substitute in negative 1 for x. We get 8 plus negative 6, so that becomes a positive 2. So we have one answer, which is negative 1, 2. That's our ordered pair. That's the coordinate where they intersect. Alright, taking a look at some more. So, looking at number 9. Probably solve for that x, so I'd add 4y to both sides. So we'd have x equals 4y plus 1. So then in our second equation, we substitute the x with 4y plus 1. And then we solve for y. So 3 times 4 is 12y plus 3 times 1 is 3 plus 5y equals negative 14. Could subtract 3 to get negative 17. Then 12 plus 5 would give us 17y. Divide by 17 and we'd get y equals negative 1. Then we can plug that in, substitute in to find our x. We get 4 times negative 1 is negative 4 plus 1 is negative 3. So our answer, negative 3, negative 1. Okay, now if we take a look at number 11, same idea. Okay, so I'm going to maybe solve for that x. So add 5y. So we have negative x equals 5y plus 14. Then we divide everything by negative 1. we get x equals negative 5y minus 14. So now I can take my other equation, and for x, just plug in negative 5y minus 14 plus 5y equals negative 14. I'm not multiplying by anything, so just rewrite it without the parentheses. Now, negative 5y, positive 5y will cancel out, so we get rid of our variables. Negative 14 equals negative 14. That is true, so that means we have infinite solutions. Alright, so let's jump back and take a look now at number 10. So here, we're taking a look at this. Probably want to solve for that x, right? So subtract the 4y. So we get x equals negative 5 minus 4y. Then we can plug it into that for x, so negative 3 times negative 5 minus 4y. Substitute in for x. That allows us to solve for the y's. So we get a positive 15, positive 12y, minus 12y equals 3. The 12y's, positive and negative, cancel to 0, so 15 equals 3. That is not true, so we have no solution. That's our third type, right? So, taking a look at number 12 now. See, now this one we don't have any ones that work, do we? But there is something we can do. Okay? I can look at this 4x and realize, well, isn't 4 really 2 times 2x? So could I solve for 2x? So I'd add an 8y to both sides. Because you don't have to have just the variable alone. You can have anything that you can solve for. So 4 plus 8y. Now just divide by negative 1. And we've got positive 2x equals, and you could divide by negative 2 and then just swap out the x. So that would work just as well. Or you could say, well, now I've got 2x, so I can substitute out the 2x and put in this and solve it that way as well. So there's often more than one way to do this. So negative 8, negative 16. Okay, add 8 to both sides. So I get 0. Negative 16 minus 7 would be negative 23y. Divide by negative 23. And I get y equals 0. Now, that means we're going to have one solution here. That's all right to have. Okay, that one's all right to have that way. So, we just take that y equals 0, plug it in to figure out what x is. We get negative 4, because negative 8 times 0 is 0, divide by 2, and x equals negative 2. So one answer at negative 2, 0. Alright, 4 more. Let's take a look at these ones. As you can see, we're getting a lot of practice with these. So on 13, probably want to get that x by itself, so subtract 4y, get negative x equals negative 19 minus 4y. So I'm picking the variables that are the easiest to solve for, because then it makes it easier when we want to substitute them out. So I substitute out x, substitute in what it's equal to, 19 plus 4y, then we simplify. 8 times 19 is 2, 7, 152. Yep, that should be correct, hopefully. May want to double check me. Then 8 times 4 would be 32y minus 6y equals negative 4. Subtract 152 would be 156, negative 156. 32 minus 6 would be 26y. Divide by 26, and we get y equals negative 6. So now we know what y is. We just plug in to our original equation there. Okay, so we get x equals 19 plus 4 times negative 6. 19 plus negative 24 would give us a negative 5 for x. So our answer, negative 5, negative 6. There's our point. Alright, number 14. Okay, so now we got y equals 3. We already know half of it, right? So we just substitute in 3 for y. That one's easy, right? We like those. So we get negative 6x minus 9 equals negative 3. Add 9. We get negative 6x equals positive 6. Divide by negative 6. And x equals negative 1. So there's our answer, negative 1, 3. Alright, taking a look at 15. So I probably want to solve for that y right there. So subtract a 6x. Get negative y equals negative 24 minus 6x. Divide by negative 1. Y equals positive 24 plus 6x. So we go 18x minus 3. Substitute in for the y. 24 plus 6x equals negative 72. 18x. So negative 3 times 24 is negative 72. Minus 18x equals negative 72. The 18x and 18x cancel out. We're left with negative 72 equals negative 72. That is true. So we have infinite solutions here. Alright. So let's take a look at 16. Alright. So this one, a little trickier to solve for. Okay. However, I've got 6y and 6y. So if I add 3x or subtract 7x, doesn't matter, I get negative 6y equals negative 3x minus 18. So I can substitute in for that negative 6y. So it would be plus negative 3x minus 18 equals 22. Combine those, we get 4x, add 18. We would get 40, divide by 4, and x would equal 10. Plug in x would equal 10. So we get negative 30 minus 18 is negative 48. Negative 6y equals negative 48. Divide by negative 6. And we get y equals positive 8. So our answer, 10, 8. That's where they intersect. Alright, let's take a look at 2 more of these. Alright, on number 17. So, well, if we look at this one, 5y and 10y are kind of connected, right? So couldn't we, well, we could think of that 10y as 16x minus 2 times 5y, right? Then if we solved for 5y by adding 8x, we get 5y equals negative 6 plus 8x on that top equation. So then I would just substitute the 5y with the negative 6 plus 8x. And then solve negative 2 times negative 6 is positive 12. Negative 2 times positive 8 is negative 16x equals 8. Negative 16x, positive 16x, 12 equals 8. That is not true. Therefore, we have no solution. Alright, number 18. Okay, I've got a 4x here and a 4x, so I can substitute a 4x. So subtract 3y, and we'd get for that top equation 4x equals 5 minus 3y. Well, then I substitute that in, so I have a negative 4x minus 6y equals negative 2. So I substitute in 5 minus 3y, and we can solve. So that becomes negative 5 plus 3y minus 6y equals negative 2. Put those together, add the 5. So that becomes a negative 3y equals positive 3. Divide by negative 3. Y equals negative 1. So I jump back up here, put in negative 1 for y. So 4x equals 5 minus 3 times negative 1. So we get 5 plus 3, which is 8. So 4x equals 8. Divide by 4. And we get x equals 2. So 2, negative 1. One answer. That's where it is. Alright, now this last one is talking about graphing 2 variable linear inequalities. So graph the following linear inequalities on the graphs below, include constraints. Ben has enough money to buy up to 8 yogurts. If his favorite flavors are blueberry and strawberry, what are all the possible combinations he can buy? Graph the inequality that shows all possible combinations of his favorite flavors. So, strawberry and blueberry. Well, he can buy up to 8 yogurts, right? So let's call strawberry S, blueberry will be B. So, he could buy just 8 strawberry, right? So, he could say, let's see, S plus B, can be, he can buy less than 8, so it can be less than or equal to 8 yogurts, right? So that's kind of what our equation would be. So if we thought about this, what if we bought 8 strawberry and 0 blueberry? Okay, well, that would be this point right here, right? He could also buy 0 strawberry and 8 blueberry, so that would be right here, right? So we could graph that. Now we know that anything underneath that would be the shaded part is a possibility, which would be that inequality right there. Which B would be kind of like X, S kind of like Y if we thought that way. So it would be Y plus X is less than or equal to 8, which we could change to slope-intercept form by subtracting X. And you'd get Y is less than or equal to negative X plus 8, which looks like that's our same graph. Okay, number 8, same idea. Peggy is buying a balloon bouquet. Favorite colors are silver and purple. The silver balloons are $1 and the purple balloons are 80 cents. Graph an inequality that shows how many of each color balloon she can put in her bouquet if she doesn't spend more than $20. So, 1 for the silver balloons. So, that would be 1 times S plus 0.8 times the purple balloons. And that has to be less than or equal to $20, right? So, S is our X, so let's just call it X. P is our Y, so we'll call it 0.8 PY. It's less than or equal to 20. So we could graph this one by changing it to slope-intercept form. 0.8y is less than or equal to negative x plus 20. Now to divide by 0.8, what would that give us? So using my calculator, that 1 divided by 0.8 is 1.25, which we want it as a fraction, so it's actually 5 over 4. So it would be negative 5 over 4x plus 20 divided by 0.8 gives us 25. So we'd be going up, so I could probably count by 1s on silver, and by 5s, 5, 10, 15, 20, 25. So my y-intercept is 25. Every time I go down 5, I go to the right one. But I set it up so it looks like this. So there's my graph. We know that she's going to have to buy less than that, so we shade underneath. And there's our equation, or that equation would work, or that equation would work, or that equation would work. Alright, there we go, guys.